Hey guys, welcome back. So today we're working on something a little bit different. This is a 48 volt DC generator capable of producing about 150 amps. This is actually brand new. It's been in the crate since new, which was, 10 years ago. So, though in theory this should run and make power, it's been sitting for a long time. So there are some precautions we have to take before going for the first start. Now, these originally were designed to charge lead acid battery banks in the telecom industry, and the person who bought this, Darren, was hoping to use it to maintain his lithium-based battery bank. It is a solar setup, but of course on days where the sun's not out, he needs some way to top off the batteries, ideally separate from the grid. So this should be capable of it. But given that it was originally designed for lead acid, likely the voltage coming out of this isn't quite right for lithium. So we're going to have to make some modifications there, but I don't think that's going to be a deal breaker. The real reason why it's here is that he wants the ability to remotely start and stop this machine. His inverter module can make calls to the generator as needed, but as this sits, this doesn't have that capability, so we are going to add it. But before we start cutting and splicing, let's get the system fired up for the first time, make sure it's working as is, and then we'll go from there. So let's actually start by getting some of these covers opened up and get a better look at kind of what we're dealing with here. And I believe this here is the access panel for the internal battery, which is actually optional. The load bank batteries can also start the machine, but that also means that the start battery, which we're not going to have in this case, is 48 volts. Well, so far it's pretty impressive. The fasteners appear to be stainless steel, and just removing a few of them gives us tons of access to the machine. So over here we now have complete visibility both to the engine as well as the generator. Now, it is my understanding that this generator is actually a golf cart motor that has been repurposed as a 48 volt generator. So definitely pretty unique. The engine is fairly standard. I believe it's a 12.5 horse Vanguard. And, looking at it, appears to be pretty straightforward as far as what's going on. It looks like we have a temperature sensor right there. We have some wires connected to ground. This right here, this is the kill wire to kill spark. And we have a V-twin engine. So this plug wire is disconnected. And we also have another wire running up to this harness going into the mixer, which I'm not quite sure if that's a fuel solenoid or something else. If it is a solenoid, it's there for safety. There's actually a few already in the system. We have a Garrettson can regulator that has a lock-off valve, so when the engine's not running, propane shouldn't flow. But as a safety, we also have this fuel solenoid and likely the one over here. Otherwise, pretty typical stuff. We got the oil dipstick there. So let's check out the other side. And same thing here. Spark plug wire not plugged in, so we'll have to take care of that. We have a nice big oil filter, the oil pressure switch right there, and an oil cooler. And over here, this is where things get a little bit less familiar. We actually have a tank inside the machine. And it's not a fuel tank. It's actually a 2-gallon oil tank. Now, this engine, it is not a dry sump system. So the oil that's in the engine is the oil that it's going to use when it's running. But on a periodic basis, the controller will activate this motor down here. And it will circulate oil from this tank into the engine, displacing what's in there. And like that, it greatly extends kind of the service interval between oil changes from, maybe 50 to 100 hours to many hundreds, if not 1,000 plus hours before you need to worry about the oil. And of course, this engine's not broken in, so I would prefer not to fill this tank because, that's going to be breaking oil. It will have to be flushed out within 5 to 10 hours. So we're going to take a closer look at that before the first start. And over here, we do have all the circuit breakers. We also have the controller in here. And up here, we have all the DC output. So this is where things can get a little bit confusing, because if you look at the labels, we have one labeled 0, which you might interpret that as negative. Then you have a negative 48 volts. And the reason for that is because this is a positive grounded system. So between ground and positive, you have 0 voltage potential. But between ground and negative, you have the negative 48 volts. So that's where that comes from. But just be careful, be mindful. When you hook up the battery positive goes to the 0 volt connection. And that is actually positive and indicated here with that red piece of shrink tubing. Anyway, over here, we have a few more things to take a quick look at. Looks like we actually have a contactor on the main output. Further down, which is hard to see, that is a DC to DC converter. And it looks like we have a couple of devices here for measuring current as well. So let's check the oil, make sure we have some. And if we do, I say we hook up the battery and see if this thing shows any signs of life. So let's check the oil. And actually, we are pretty low. We're just barely on the dipstick, and we should be kind of somewhere in this range, ideally closer to the top. So we do need to add some oil to the engine before trying to turn it over. So we're going to top it off with 42 ounces of oil. Now, the manual for this machine, it does not say what grade to use. But in my environment, 10W30 is usually the best. The manual does go out of the way to say that you have to use the Delta brand oil, otherwise engine damage could occur, which I don't quite believe, being this is a standard Vanguard. So that's 32 ounces, 10 more, and we'll check the level. And after the break-in, synthetic is recommended, but for break-in, standard mineral oil, that is the way to go. Yeah, and we're right on the full mark. So, perfect. And there is a little bit of oil in that tank. It's just a very thin coating on the bottom. So definitely far less from the 2 gallons that should be in there. So I'm going to put maybe a couple quarts in there. I think we can disable that function in the controller, which would be my preference, at least for the break-in period. But we'll add a little bit in there just in case that pump comes on. And just because it's new doesn't mean we don't have a mouse. 10 years is a long time. Yeah, airbox nice and clean. No sign of a critter. So now that we have oil in the engine, I do want to crank the engine, not to start it, but to get the oil circulating and just confirm that we're building oil pressure. Now, the other thing to consider too is that this engine hasn't rotated in 10 years, so I'm thinking we should pull the plugs, get a little bit of oil in there before cranking it over. Now, that actually brings us to the next problem, the battery. This requires a 48 volt battery to crank, and of course we need one to test with. So Darren thankfully included that, but the battery, it is sitting at 3 volts. So initially I panicked, and then I realized I think the battery management system shut down the output, and we do have a controller right here, which we can connect up to the battery. So, I think we should do that, see if we can turn the BMS on, and hopefully this battery has some voltage in it. Otherwise, we're going to be dead in the water. And the cable that came with this, we'll just plug into the controller like that. And it looks like we plug in right there. And it is keyed, so you can't plug it in the wrong way. So we're still sitting at 3.05 volts. Display is off. Let's hit the button. Okay, it's in standby. 23% state of charge. So that could be an issue. Our testing is going to be somewhat limited because we need to get this battery charged. And the generator is the only thing that can do it. So we need to get that out of standby. And I'm guessing potentially DSG is it. Let's take a look here at page 3 if we can. Yeah, and that's just a bunch of information. So that seems to be the only thing we can toggle. So let's toggle it. And the meter's going crazy, so that's probably a good sign. Yeah, there we go. 51.7 volts, so that is a very good thing. So let's turn this back off for now. And once we get the battery fully connected, we'll turn it back on, and we can test cranking the engine. So to hook the battery up, we're going to hook it up as the load, which isn't ideal. I only have one battery, so we could hook it up as the start battery, and then we'd have nothing for the load. The other thing to consider too is that, I don't want this to immediately charge the battery. I do want the engine to run a little bit before putting the engine to work. So we might be able to disable the output based on the fact we have a solenoid there. But for now, I don't see that we have any other choice. So this terminal, it's a little bit awkward in that, there's 2 places, I guess, to hook up outputs. But the size of this ring terminal is such that, it will fit on, but we're going to have to remove the nut from the far one to fit it, and probably use some washers to get a nice tight fit. So let's do that. And I think it might be in order to add a little bit of protection here, although it's not rubbing very hard. You know, I would hate to short this out at 150 amps. That would make some pretty good sparks. All right, that should be good. And if this was a negative grounded system, you'd want to hook up the positive first. In this case, since we have a positive ground, we want to do negative first. Now, this battery didn't come with any hardware, so it does use M8 1.25 volts, which I have, although the thread's a little bit long. It doesn't go all the way in, so we're going to have to use likely a washer or two to space it out. And that terminal might be a little bent. Yeah, let's straighten that out a little. And before we bolt that positive terminal on tight, let's power up the BMS again. And I want to do the tap test. I want to make sure we don't have a massive short circuit in the system, which we shouldn't. Okay, battery's online. Let's do the tap test. Okay, so that is a good sign. I'm going to shut the battery off again, and we'll get the last wire resecured. All right, so let's turn the battery on. And so far, so good. Of course, we don't have any signs of life because all the circuit breakers are turned off. So we have a couple here of interest, like the controller and the battery. Now, this battery, I'm guessing, is for the internal battery, which we don't have. We also have the output load circuit breakers, 4 in total, which I'm hoping we don't have to turn that on, but being that we're connected to the load side, potentially we're going to have to. But let's start with the controller, see if we get any power. And we don't. Oh, I take that back. Came online. You know, it says we have a minor alarm, and I'm guessing that's just like an open door alarm. Yep. So that minor alarm went away as soon as I clicked that switch. So good. At least the electronics came online. So let's see if we can crank the engine. Although on second thought, let's kill the power again because I'm going to get some oil in the cylinders. You want to make sure that top end is lubricated before we turn the engine over. Wow, those are maybe over torqued. Ooh, there we go. Yeah, not completely new. I can tell the engine has been fired on this plug at least once. Or maybe it's just a little corrosion on the strap. I'm not sure. But plug looks relatively new, if not brand new. So I'm just going to use a bit of fogging oil to spray in there. And I'm going to leave the plug out. You know, we'll crank the engine over first without compression. Let's do the same on the other side. And same thing on this plug. Looks a little discolored on the strap, so potentially this has been run. It'd be nice if they broke it in at the factory, but there is no documentation showing that, so we got to assume the worst. And this is where things get a little bit interesting. So I was hoping to use the Lone Wolf 6000 to crank this engine over. All we need to do is connect it to the solenoid on the starter. But if you look over here, there's no starter. And if you look on the other side, there is no starter. So this engine does not have the typical electric start. I think it's actually the go-kart motor, aka generator, that actually cranks the engine. So unfortunately, we can't do this a low-tech way. We're going to have to use the computer to crank this engine. That said, though, there's no reason why we can't turn this by hand and at least make sure the engine's not stuck. And no, rotates fine. Feels nice and smooth. And we're also going to test for oil pressure. So I'm going to unplug the sensor. And usually I would use a test light to kind of visually show this. But being a 48 volt system, I don't have a test light that can handle that. So instead, we're just going to use the multimeter and we'll test for continuity to ground. Without oil pressure, we should have a connection to ground. But once pressure is built, that should go away. So just get these leads connected to the multimeter. This lead is connected right over there to engine ground, and the other one to the oil sensor. So we could test this in continuity mode, which would make a beep. In this case, I have the meter showing resistance. So we have a pretty low connection, about 15 ohms. If we flip this over to the tone, we have a connection. But when we crank the engine, once pressure is built, that should open up, essentially, as if we're disconnecting the wire. So if I disconnect the wire, it's going to go to that mode right there, the blinking 1, which indicates there is no connection. So let's get that back on. We'll turn the battery back on, crank the engine until that opens up. All right, so let's turn the battery back on. Okay, battery's on. We'll turn the controller on. And the controller is now powered up. So all we need to do is hit run and it should crank the engine. Now, obviously we have no fuel, so it's not going to start. But let's crank the engine and see if we're building pressure. And I heard something click, but engine not rotating. So I'm wondering if the output breaker has to be turned on. So let's put this back to off. Maybe we'll turn the battery breaker on first, although again, I think that's for the internal battery, but let's start conservative. Let's try to crank it again. And now. Just hear a relay clicking, so I think we need to turn on the main output in order to do this. Let's try it again. Yep. Engine's turning over. Wow, that is quite a starter, but we have oil pressure now. That is open circuit. So that is a good thing. So now everything's lubricated, the top end, the bottom end, and it should be safe to start. Now I'm just waiting to see how long it takes for the pressure to drop and that switch make a connection again. And the fact that it's holding pressure for so long is a very good sign. Now, what I'm not crazy about is that we have to have the output on to crank the engine in the current configuration. So potentially we might move things around, and there we go. Looks like the switch is now allowing a connection. So cool. Engine cranks, and we have oil pressure. So let's get this reconnected to the controller. And we'll get the plugs reinstalled as well. Now, I did check the gap. It is tighter than 30 thousandths, which is fairly typical on a system like this. Usually around 25 to even 20 thousandths on some, running on propane or natural gas. And with the plugs back in, this should be ready to go. The oil is filled up properly. The air filter looks good. I assume we have spark. All we need to do is add fuel, and this thing should fire right up. That said, we can't do that quite yet. This is not configured for a lithium iron phosphate battery. And there's some other settings in there too we need to check and change, like disabling the auxiliary oil tank, at least for testing. So to do that, there is no direct way. There is no screen to look at, but we do instead have an Ethernet port. So if we can get on that network, the controller has a web server that we should be able to connect to. I guess the only thing I'm not sure about is how old is the web technology and is it compatible with modern browsers. So yeah, let's take one thing at a time. Let's get on the network. We'll pull up the web page and go from there. All right, so I'm going to turn off this main output. We don't need to crank the engine, but we are going to turn on the controller. So the BMS, it is active, so the system's going to boot up. And what I'm going to do is plug in the Ethernet cable. The other end's on my computer, so I'm going to use a screen recorder. So hopefully you can see it, although that cable isn't locking in place, so I think the tab is a little damaged. Let's try it again. All right. As long as we don't pull it, it should work. So if everything's working, you should see my screen now. Want to make sure Wi-Fi is off, which it is, but we're not indicating a network connection, so we might need to manually configure that. Yeah, 169.254, that is essentially no IP address. So to do that, we just need to go to the network settings and find the Ethernet controller. So let's check the properties of that. And IP assignment, it's set to automatic. So this controller must not assign addresses automatically. So we're going to assign one manually. It is an IPv4, and a lot of this you guys don't need to know, but basically we're getting on the network. So the controller should be at 1.1, so we want to set our address to something different, as well as our subnet. And the gateway, probably don't need to worry about this, but we'll put it in anyway. And that should theoretically be it. So we're going to hit save. And it doesn't like something. So check one or more settings. So that's pretty vague. Let's put a DNS in there just in case that's what it's complaining about. And no. So very interesting. I thought we'd have issues on the controller side, but it looks like the Windows side isn't happy. So let me see if we can configure this somewhere else. All right, so we're back, and I'm going to cancel out of this interface. This is the newer Windows interface for configuring IP addresses. This has been buggy since day one, And I think that's what's going on here. So yeah, this is not a tech channel, so I'm not going to go into too many details, but I'm not going to use this modern interface. Instead, I'm going to use the old control panel, which still exists apparently in the newer versions of Windows. And this is what I traditionally use to configure, network settings. So hopefully this doesn't suffer from the same problem. So IPv4 properties, we're going to set it to manual, and we're going to do the same thing. 192.168.1.100, and the net mask for the subnet populates automatically, which is nice. And all these other settings we don't need. So I'm just going to hit OK, and it took it no problem. And if we go back to here, clear the screen, check the IP settings, and yes, we're on the correct network. We're on 192.168.1. So now if we open a web browser and go to the controller at 192.168.1.1, that should pull up the page. Now I guess the question is, do we need to tell it the protocol? I don't know, but let's try it. And yeah, look at that. So that is the web server. Now, there's nothing else on the screen, so that tells me we are dealing with a compatibility problem. So we do need to, I guess, enable legacy mode, which likely is not enabled by default. So let me dig around a little bit. And you know what? I'm not in Internet Explorer, so that could be the problem as well. So, well, Internet Explorer is gone, but there is Microsoft Edge, and you can run that in IE mode for older systems. So let's try Edge, in its native mode, and same thing, it seems to be broken. So we need to turn on compatibility mode, which is either in settings or tools. And yeah, I think this is it. So under default browser, it says make Microsoft Edge the default. But we also have a setting here that says allow sites to be reloaded in Internet Explorer mode, IE mode. And it just says default. So I'm going to change that to allow. I'm not sure what default is. And we need to restart the browser. So that's fine. We'll restart it. And we still have the page open. So at this point, it's not running in compatibility mode yet, which is why we see what looks like a broken link. So there should be a setting here where we can choose to run this in compatibility mode. So let me look for that, and then hopefully we'll be in. So I think I found a workaround. It's not quite the way Google says it should work, but we can manually add the page right here. So 192.168.1.1, and it says the format is incorrect, which is not true. So maybe it wants the protocol again. Yeah. So we'll add that. Okay, that is added. And I think we can close these pages. And let's open up a fresh page and see what happens. Okay. And this is different. So it is talking about Java support, that it uses Java. So actually, even in IE mode, we may not have the version of Java we need. And yeah, it's still broken. So this is going to require a little bit more research, I think. So we might have a solution here. There is something actually called the chirp-j applet runner, which we can add to Chrome. And that will run Java apps, which are not supported by modern browsers. So we may not even need IE compatibility. We just need Java. At least that's my hope. So once this is installed, we might need to restart Chrome. And then we'll try Chrome with this extension and see if we can load the page. So we're going to pin this extension as it suggests, and let's open up a new tab here. We'll go again to the same page. By default, it's not going to run because Java is not enabled, and actually we're connected to Wi-Fi, so we need to disable that again. Plug in the Ethernet. And now we are plugged into Ethernet, so let's try refreshing the page. And there we go. We get the Delta logo with a broken link. So let's click on the chirp J. We'll enable it for this domain. Allow. And pretty much the same thing. So yeah, things aren't quite going as planned here. And I guess, this is one of the problems with, putting web technology in a machine that might last 10, 20, 30 years. Modern web browsers might have an issue, but it looks like something is happening here, finally. Question is, will we get a login screen? And yeah, something happens, but I was going to say it's not working, but look at that. So the Java app did load. It's a little sluggish, but that's okay. We're just doing some basic settings here. So I'm going to spend a minute and go through this. There's actually a lot more information here than, I expected to see. According to the user manual, it has actually very few settings. A lot of these, obviously, we don't need, but I'm guessing setup is important, although that looks pretty blank. So yeah, this isn't quite what I was expecting to see. We did not even get a login prompt. So yeah, let me look around for a minute. But this is a good sign. At least we're in to some extent. So yeah, something's definitely not right here. I'm guessing we're still having some Java compatibility issues because for the most part, absolutely nothing is populated. So yeah, I think we have a compatibility problem. So let me look around. I might have an old computer that still boots up with an older version of Windows. So if we have that, that's going to simplify things quite a bit. All right, so let's try this again. I installed Java 8, both the 32-bit and 64-bit versions. I'm plugged back into the controller, so let's make sure I can still talk to it. And yeah, I'm getting a reply from the controller, so that is a good sign. As far as Java goes, we do need to make sure it's enabled or allowed within web browsers, and that behavior might be turned off by default. So we're going to go to the Java control panel, go to security, and it is enabled. And I think we want to add the site to this list. So when we go to the site of the Delta controller, it should automatically be allowed. So that should be good, although I don't see it in the list, so I must have done something wrong. Let's try it again. Yep, we'll ignore all the warnings. Java was retired from web browsers for a reason. It's definitely a security threat. But now that Java is installed, we're going to open Edge back up. And we're going to try going to that page again. And it's not a secure connection, so let's take out that S. And let's see what happens. Okay, this is good. It's trying to run Java, so we're going to allow that. And it's thinking about it. Okay, well, we got further than we did before, but we do have some sort of error here. So it says click for details, and so yeah, I guess I'm going to ignore this unless I can allow it. Which, yeah, this could be an issue. So yeah, not easy to configure the controller for sure. You know, they didn't need to use Java to do this. And 10 years ago, it might have been a good idea, but now, not so much. So as you probably can tell, things have escalated. You know, I got nowhere trying to get Windows 11 to work, so I made a trip to the basement, found 3 old laptops, one of them turned on, and it was the right version of Windows, Windows XP. So I had to install a screen recorder, which hopefully works. I've never used it before, but with any luck, you can see what I'm seeing. You know, I configured the network exactly the same way using the old utility, which is what Windows XP uses. So we're now on the 192.168.1 network, and we should be able to ping the controller at 1.1, and we can. So I'm going to fire up Internet Explorer, and if we enter the same address as we did before, with any luck, Java will actually load, being that Windows XP, well, isn't known for security. So it's thinking about it. And Java is loading. Okay, and this was actually the problem we had on the other machine. It was just blocking it. This one, basically you can choose to ignore it and run it anyway, which is what we want to do in this case. And I'm hoping, yeah, it loaded just fine. So we're only supposed to see 2 tabs, and that's what we see. And on the display tab, that is the data that we are looking for. So let me scroll down real quick. We'll just take a quick look at some of these settings. You know, most of them are probably fine. Really, the big thing I wanted to do was disable the oil swap and also configure the high voltage and low voltage limits, because you know the way this is going to work, it's not actually going to be run in automatic mode, but if it is, you know, I'd like the limits to be at least somewhat reasonable. So, you know, I'm going to set the low limit to 50 volts. And the charge limit I know is 56.2 on Darren's battery bank. So I'm going to set that as well. We might actually need to set it higher, but actually the current value of 57 might be fine, but we can circle back on that. For now, we'll just do 56.8. So in auto mode, it'll turn on if the voltage drops below 50, and it will shut off, you know, once the voltage hits 56.8. So that looks good. Not all these fields can be edited. You know, if they don't have the edit button, then, you know, those values can't be touched. But in this case, I'm not too concerned about, you know, the default settings as far as exercising. You know, the fuel type, it is set to propane. You know, date and time doesn't matter too much. And I think I just saw the oil exchange. Yeah, so number 19, oil exchange, enable, disable. So let's disable that. And hit set. Okay, that appears to be off. And we'll do the same for the hot exchange. It says off, although there it says on, so something's not quite right. Let's see. Okay, now that does say off. And yeah, these other settings here are view only. And these other settings I don't think we care about. So this should be good. So I'm actually just going to close the window real quick. I'm going to open it back up, make sure that those settings got saved. But I think we finally got this configured. Now, I'm going to edit a lot of this out, but I probably spent about 2 hours trying to get Windows 11 to talk to this thing. And with Windows XP, it was a no-brainer. I think the hardest thing was just getting the screen capture working because that software wasn't on this machine. And yeah, looks like we're good. 56.8 is the high, 50 is the low. And if we go down to attribute 19 and 20, we can check the exchange settings. And yeah, they're both off. So looks like the controller is configured. All right, so now that we get the controller configured, this should be able to run in automatic mode. You know, we might need to tweak the settings still a little bit on the voltage side of things, but you know, as it is right now, it should be fairly safe to run. Now, this didn't configure the charge voltage or the amps. And that is a concern because to charge this battery, you know, I think the ideal charge voltage is around 56.2 volts. It's actually a range, so that's the lower side. I think the higher side is around 58.2. You know, according to the documentation, this is configured to output 52.5 volts. So we need to change that. And the other problem is that this is a single battery that's rated at 102 amp hours. So the manufacturer only recommends charging this at 30 amps. You know, the max is likely somewhere around 50 amps, potentially 100 amps. But this machine, it's going to put out 150 amps. So that actually, I think, can be configured as well. You know, this golf cart motor, it's made by Alltrax, and behind here is the DC to DC converter, which goes along with that motor. And from what I've read, there should be a USB plug on there, and we can connect in and configure both the output voltage as well as the amps. So let's get this panel removed and gain access to that USB port. All right, and this is what we're after here. This is the Alltrax controller for the Alltrax golf cart motor, and I believe the USB-A port, a little bit hard to get to, but it is right there. So let me find the cord, we'll get the software installed and see if we can configure this for our needs. And that's the cord right there we need. So USB-A to USB-B. So I'm going to get this all plugged in, we'll get the software loaded, and see what we can do. All right, so we got the cable now plugged into the Alltrax controller, and I also loaded the software onto my Windows 11 machine. So right now the software is loaded, it's all blank, but when I plug in the USB cable to the laptop, it should power the Alltrax module and identify. And yeah, that was pretty much immediate. So now we have access to all the settings, keeping in mind this was intended for a golf cart. So not all these settings we need to be concerned about. But the first one is the over voltage. So that is set to 52.4, and this is the voltage coming out. So 52.5 is what the manual says, 52.4 is what's actually configured. In our case, we want to set this to 56.8, which is safe for the battery we're using and actually ideal. And then the next setting is the amperage. Now, this being a golf cart motor, you know, this setting here is likely the output to the motor. This generator actually uses the regen function of the motor to put power into the battery. So I think this is the setting right here, but luckily someone else has already done what we're trying to do, and they have indicated what we need to do. So the over voltage we set, and the other one actually looks like it's on the second tab here, user 1, max regen battery amps. So let's go to user 1, and we have max regen battery amps. So this is kind of interesting. So this is set to 50 amps. And I was expecting to see this at, 150. The specs on the machine says it's 150. I mean, technically it actually says 144. So yeah, let me poke around a little bit and just see if there's anything here that's more appropriate. And here we have max regen battery amps at 100. So that's interesting. So between the two, they do add up to approximately the 150 we're looking for. So I'm not sure why it's split out like this. So yeah, let me do a little bit more digging before I commit. But, I think the easy thing to do here would just be to reduce these so that they total, the 30 amps that I'm looking to do on this battery. So yeah, give me a minute. Let me do a little more research on this, and then, oh, actually, look at this. So under normal, it does say 150. Okay. So let's exit out of here. And what I'm going to do is export the settings before I make any changes. So that way we can always go back to how it was. All right, so I'm not sure what happened there. It seems like the screen recording stopped when I went to save to file. So I'm going to try it again. I'm not sure if it's related to that. Potentially you might get kicked out again, but that's the file I saved. I'm going to save, I guess, a different version of that. And the process is running right now, so it's exporting the configuration. So in theory, we can get back to where we are now if something gets really messed up. Anyway, the settings are saved. So now we need to set everything where we want it. And we did kind of switch this earlier, but I did not save it, so we got to do it kind of one at a time here. So 56.8 is the output voltage, so we're going to set that. And it writes it to the controller. I think it reboots it, so it actually disconnects and then reconnects, which it just did. And then we have these user tabs here. So I had to do a little bit of research on these. I didn't understand why we had 3 tabs with essentially the same fields, but different values, at least for the max regen battery amps. So under normal, we have the 150.3, which seems correct for this machine. But on user 1, we have 50.3, user 2, 100.2. So I did find the Alltrax manual, and it talks a little bit about it. Essentially, these are different profiles, and in this example, they said you could add a toggle switch to a pin on the controller, and when you turn that switch on, it'll toggle user profile 1, in this case, meant for kids. So it's going to have reduced power. So these are different profiles, and I guess depending upon whether you have the toggle switch attached to the right jumper, it enables or disables these custom profiles. So I assume we're running under normal since it is set to 150 amps, which is correct for this machine. In this case, for this battery, we only want 30 amps, so we're going to set that to 30. And just to be safe, I'm going to configure the max regen battery amps as well on user 1 and user 2. And I'm going to set them lower. So like user 1, we'll set it to 10 amps. We'll set that. And once that saves, we're going to set user 2 to 20 amps. That way, when we get this machine fired up, we can measure the current and tell pretty quickly which profile is actually being used. But based on the settings, I would suspect the normal profile is being used in this case. So we'll set that and let it save. And it's all done. So I'm going to unplug the USB cable altogether, plug it back in. We'll just double check the settings, make sure they're all there. So 56.8. User profile 2, we have 20 amps. User 1, 10 amps. And normal, 30 amps. So yeah, that is pretty much perfect. So we're going to get the USB cable unplugged. And initially I thought the USB port was the one here on the left, which you probably can't see. Let me get you in there a little better. Yeah, now you can see it a little better. So initially I thought the one on the left was the USB port. That is not the case. There was actually one on the right that had like a dust cover over it. So I'm going to get that cover back installed. We'll get this protective piece of paper wrapped back on the front and get everything else together. And just for the record, I am going back in here to adjust the high voltage alarm because we set it at the charged voltage, which is pretty much going to alarm immediately. And that is actually the low side of the charge voltage. So, you know, we can probably set that to 58. And that way it's not going to falsely shut down the machine. You know, most BMSs will shut down at about 60 volts. And 58 should definitely set the alarm. That is high. You know, it should be fully charged at that point. So that change has been made, and automatic mode should theoretically work. So let's get this machine outside. So we're just about ready. The propane is hooked up. I'm just going to check it real quick for leaks. You know, technically we don't need 2 tanks for this. If we do run at 30 amps at the voltage we're at, it's going to be around 1700 watts, which isn't that demanding, but I don't want to take any risks here with the break-in. I want this to run and start properly. Connections there look good. We'll check the T. Good. And that connection's also good. So we're going to start it in a minute. We do have the amp clamp on the wire so we can see exactly how much power is going into that battery. We want to see somewhere around 30 amps. If it's above that by too much, you know, we're going to have to shut it down pretty fast. We also have the voltmeter connected to the battery. Currently it's at 3.19 volts, but that's because the BMS is off. So let's turn that on. And once it's on, this is going to go up to 51.4 volts. So that is the starting point according to this meter. You know, once running, we'll check in on these gauges. We'll check in on this as well. But there's also an iPhone app to monitor the same details. So I'm going to try to get that running, and then I can put it directly on your screen. So let me get that set up, and then we'll hit the button, see what happens. Okay, so it is the moment of truth. So let's turn on the battery output. We'll turn on the controller. We'll give things a second to boot up, and then we'll hit the run button, and hopefully things go as planned. You know, if we configured it right, it's going to charge at the right voltage and the right amperage, but that is to be determined. So yeah, I guess there's nothing to do but try it. So let's hit run. So far so good. Engine sounds good. Let's see what's going on over here. Yeah, we're putting out, it's fluctuating between 12 and 17 amps, so a bit lower than I'd expect. So we'll keep an eye on that. That does seem a little bit odd. Let's see what the app says. Yeah, and the app seems to agree. It's showing it close to 10 to 13 amps. And that's what we're seeing over here as well. So it might be using a different profile, you know, maybe the 10 amp profile. So we'll let this run for a few minutes just to get the engine warmed up a bit. And I'm thinking we need to go back in and bump up the other user profiles to figure out which one it's pulling from. Alright, it's been running for about 10 minutes, and the engine has a good amount of heat in it at this point, so I'm going to shut it down and reconnect to the Alltrax controller and play around with the settings. I want it charging at a higher rate, at 30 amps if we can. So, let's shut it down. Interesting, so it's doing a low speed cool down. So the engine's actually idling right now. And of course the meter turned off. Let's see if anything's coming out. And that's interesting. I'm going to kill the battery. It's actually rotating the engine with the battery. That does not seem right, so I'm not sure what happened there. Very odd. Yeah, it makes me wonder though if that's by design. Just a cool down phase, using the battery bank to spin the engine. Yeah, no fuel would be going into the engine, it would cool down better. And that light was actually blinking, so I think it was doing that by design. So I might have panicked a little bit. But, you know, that battery, we didn't put much charge in it, so I really don't want to do that until we build up maybe about a 50% charge. So let's go back in there. We'll bump up the amperage settings and try this again. And we're plugged in again. So let's see, the normal profile was set to 30 amps, which clearly it was not doing. So I'm going to set that one to 10. I don't think that's the profile that was used. We're going to set it. And then we're going to go over to user 1, which I believe is the one that it was actually using. And as soon as that finishes, we'll go to user 1. And this one was set to 10 amps. So let's bring that up to 30. Set it. And try it again. All right, let's try it again. This time, hopefully we see 30 amps. Yeah, interesting. It actually looks like it's lower. So I'm not sure what to think about that. Maybe we had the settings right. So I'm going to let this run for another 5 minutes or so, and then we'll try adjusting the settings again. Actually, I may have spoke too soon. According to the app, we are putting in 30.8 amps. And look at that. Actually, it did come up quite a bit. So there must be a warm-up period where it doesn't go to the max that it can do. So yeah, 30 amps. I guess the thing that doesn't make a whole lot of sense is that the user 1 configuration, I think out of the box said 50 amps. And, well, this machine should do 150, so I'm not sure why that was set. But it does seem to be using user profile number 1. So good. We'll give it some time. We're at 23% state of charge. So let's bring that up a bit, maybe closer to 50%. So it's been about 8 minutes and everything is running absolutely perfect. You know, the engine sounds great. And according to the app, we're now at 27%, and the incoming amps, 30.53. So if we come over here, that closely agrees. We're at 29.56. This meter says 53.9 volts, and it's going up. The voltage in here is actually 53.56. So, yeah, little difference, I guess, but for the most part, they are reasonably correct. So I would say we got another 30 minutes or so before reaching a 50% charge. So once we're there, we'll shut it down. So we just passed the half-hour mark and no issues at all. This thing has been running absolutely perfect. The state of charge, it has come up to 41%, and we're still putting in just about 29 amps. Voltage is coming up to 54.7, 54.8 volts, and it continues to climb as the state of charge goes up. So at this point, I think I'm going to call it. Let's shut the machine down and get this back inside. And now it is the golf cart motor only spinning that engine. So it is pulling close to 56 amps from the battery to do this. And I think it does it for about a minute and then does the final shutdown. All right, we got this machine back inside, and for the most part, the testing went quite well. I guess the only thing that doesn't make a whole lot of sense is that it seems like the user profile 1 is the profile it used. And out of the box, that was set to 50 amps, and this machine can produce 150, and that's what it should produce when connected to a larger battery bank. So I'm not sure why it chose profile 1. Potentially it chooses a different profile based on whether you hit run or auto. And I guess the other possibility that comes to mind is that maybe it always starts at profile 1, which was 50 amps, goes to profile 2, 100 amps, and then as the machine warms up, it goes to normal 150 amps. But in the testing we did, I didn't see that. So when sending this back to Darren, likely I'm going to set all the profiles to 150 amps, but I'm not sure. I need to do a little bit more research on that. Anyway, that brings us to the last issue, enabling remote start. And initially, I wasn't a big fan of it. I didn't understand why he would want to do that. Just set this to auto and the controller will take care of the rest. But, after speaking with Darren, it kind of makes more sense. And I guess first off, his Grid Boss controller, likely you can control it remotely. So, in that case, you can start and stop the generator as needed. So if you want to put in only 20% charge, you can do that. The other thing to consider too is that in auto mode, it'll start automatically and it will not stop until the batteries are 100%. And in the case of a solar setup, you may not want that. Potentially the batteries are low at 20% because it's a cloudy day. So the generator starts and then maybe 10 minutes later the sun comes out. So in that case, the solar production picks up and there's no need for the generator. So the Grid Boss controller will shut the machine down and or start it as needed. So it makes perfect sense to have remote start, kind of with that in mind. So there is one way that is kind of native to this machine. So we're going to try that real quick. There are some shortcomings to it, so we're going to try something else as well, and then make a decision as far as how to proceed. And the native way right here is this remote disable. So by shorting these two pins, you disable the machine. So I guess the question is, when you re-enable it, does it resume running, or the last status that was in? So we're going to find out. I'm going to turn the battery back on, and we'll turn the controller on. And we are online. So I'm going to jumper these two terminals. Right now we're obviously in the stopped state. Okay, and when it's jumpered, we have a blinking red light. So that is presumably visually showing us that it's disabled. Let's try putting it in run. And no, it ignores my input. So let's re-enable it. I have the battery, the main lead coming in turned off, so I'm going to hit run. The engine's not going to crank, but we're going to hear the relays click as it's kind of going through the motions. And let's disable. All right, so now it went to stop, blinking light, so we are disabled. And if we unshort it, the question is, will it go back to run? And yes, it does. So it seems like this might be a viable solution. This is the most native way to do it. But there's a few things I don't like about it. It's kind of, if we set it to run and then disable it, it's depending on this wire to always make that connection. If for some reason that fails, then the machine's going to start. Now, obviously, we're not going to use a wire. We're going to use a relay. And his charge controller, it has a relay in it, which actually closes when it wants the machine to start, which is the opposite of what we need here. So we'd have to add another relay in the machine that is normally closed when it's not powered, and that would essentially keep this shorted out. And then when his controller calls for power, the coil in the relay would energize, opening this connection, allowing it to run. But again, not a huge fan because, if that relay fails, it's going to default to run mode, and it's going to run indefinitely. So there has to be safeties in the system to prevent the batteries from overcharging, and there are. I guess the charge controller itself can open up its contactor and basically disconnect the generator from the battery bank. So that's one safety. The second one is on the batteries itself. When they reach kind of the high voltage mark, which I think is 60 volts in this case, the BMS systems will also disconnect. So this isn't a terrible idea. It's definitely the easiest. I guess the other thing I don't like about it is when you have it shorted out and the light blinks, I'm not sure if you can hear it, but there's actually a mechanical relay clicking on and off about once a second. And that relay, although I'm sure it's good quality, blinking once a second, it's only going to blink for about 2, maybe 3 years. And then that relay is going to be dead. So, is that going to cause a problem with the machine? I don't know, but I don't think so. Likely that relay is only used to blink the light. So I'm thinking worst case, the light will either get stuck on or stuck off, but the functionality should theoretically still work. Anyway, I have another idea. Let's turn the power back off and actually pull out this panel right here. I want to see if we have any access to the buttons, because we might be able to simulate a button push, which I like the idea of better, because when not running, it's going to be in the stop mode, and we don't need to maintain a connection to this to stay in the stop mode. The other benefit, obviously, is that the relay isn't going to be clicking indefinitely. I guess the downside is it's a little bit more complicated, because you have to simulate a button push. You can't, just use a standard relay, which is essentially pushing a button and holding it indefinitely. There's actually, I think one of these buttons, if you push and hold for more than 5 seconds, it indicates you want something else other than stop or run. So it has to simulate a button push, but that's getting way ahead of myself. I don't even know if we can do that. So yeah, let's get the panel off. Let's get this board out and see what we can do. I already removed most of these screws, so I only have one here on the top and another on the bottom, and this panel will come off. Yeah, everything is nice and neat, top quality. Down here we have a controller, which actually I believe is a PLC controller. So, technically we could probably get into that and program it, but from what I've read online, it is password protected and no one has managed to get in. So I think, the programming is what it is. In this case, we only need to simulate a button push. So we need to get this off as well. I can see there is a board on the back side, but this whole thing is held in just by 2 screws there on the top, a couple more on the bottom, and this module should pull out. We have to be careful though, because obviously there's a lot of wires connected to it. But given the way this is constructed, it likely can just be unplugged, and then we can take a closer look at it. Okay, and just 3 screws actually holding that in. And it looks like maybe 2 harnesses going in. One is just an Ethernet wire, which we can unplug from the back. So that is unplugged. And yeah, actually I was wrong. There's 3 harnesses. All right, so we're in, and it looks like, we have the stop and the run on this side, and these pins poking through here, these are actually the LED lights. So the switches, they must be surface mount of some sort on the other side. We don't have access to it directly. So we may need to tap into that directly, but I'm kind of hoping we can do it over here at the wire harness, which appears to be the section for the buttons. We do have 2 other harnesses down here, which looks like one of them is definitely for these monitoring outputs, as well as the fuel refilled button. But most of those traces, at least the ones I can see, are definitely heading this way. So this harness is out. most likely that harness is out and we're left with this one right here. So it is labeled, and if I can zoom in enough, you can see it. So this appears to be 24 volt, at least according to the label right there. And actually that wire is red, whereas all the others are black. And over here, we do have one labeled 24G, which I'm guessing is the ground. So the switch should be connecting ground to one of these other terminals. You know, both the off switch and the on switch. So I'm going to try to probe, holding the leads on, you know, ground versus another terminal, and then we'll hit the button and see if we get what we get. Now, this is going to be hard with only two hands, so I'm thinking it might be better to probe in there, although those pins are pretty small. I'm not sure I have anything that's going to fit in there without potentially damaging the pins, but let's try. Actually, let's back you up a little bit. And no, that's way too big. And this is a tiny little needle probe. So yeah, we're going to have to maybe get a third hand, or potentially clip onto those. But again, they're so small, I'm not sure we're going to be able to do that. So let me probe around a bit, see if we can find out what pins we need to worry about here. Seems like that one. Let me hold there. Now unclick. Click. Okay. So we think we found the off button between 24G and this terminal right here. So my son's actually going to push the button. Push it. And then let go. All right, can you find the other button, the run button? Is that it?
Mm-hmm.
Are you pushing?
Yeah.
Let go. Push. Click it back and forth. All right, so that's it. So the run button is this one. The off button is that one. And it's connecting from, appears to be connecting from 24G. So I think we got kind of lucky on this. Although I don't want to count my chickens before they hatch, because originally I was thinking I'd have to modify the board, but based on the testing we just did, I think we can just tap into these wires. While testing it, I took a look at the resistance as well. I was kind of curious if it was going through a resistor, because, signaling a processor to do something, you do need to go through a resistor. But in this case, it was a very low direct connection, no resistor in line. So I think all we need to do is touch the wires in question for the function we want. And theoretically, that should do it. Of course, my big fear, though, is that if I do it wrong, we could smoke this board. And finding a replacement might be a little bit tricky. So this is one of the wires in question, so I am going to cut it in the middle. I believe this was the wire to trigger run. And then I'm not going to do the off wire yet. Actually, I think that was the stop wire, so we're not going to cut the run wire yet. Let's find the ground. And we'll cut that as well. And hopefully we do this right. But we have 1, 2, 3, 4, 5, 6 wire, right? 1, 2, 3, 4, 5, 6. So the 6 wire. We already cut the second. That's 3, 4, 5, 6. And let's just double check that. 1, 2, 3, 4, 5, 6. Yeah, that is the 6 wire. That is the ground wire. So obviously the board needs ground for other functions as well. So we're going to have to tap into that, but still allow the ground through. And actually the same for this wire. I mean, ultimately we want to be able to control it both from the front of the board as well as remotely. So what I'm going to do is, well, cut the wire, and we'll reconnect the wires, but also have leads coming out of it so that we can test, touching the two together and see what happens. Okay, we get a little wire exposed there. We'll do the same over here. Okay, let's double check that those are the correct wires. So we get one lead on the ground, and the other lead on the button, which this case, I think this is the off button we determined. So no connection. Let's push stop. And there we go. Nice low connection, about an ohm. And I'd say most of that's just the resistance in these wires. So that is good. That will shut the machine down. So before we go cutting the run wire, let's test that we at least have control of one button before cutting another wire here. And I was thinking we could use a Wago connector, at least for testing. I think we're not going to use this for the final thing, but something like that should get us what we need. Maybe. I'm going to double up on one side, which is not the correct use of a Wago, and it may not work. But that is a secure connection. We'll do the same on the other wire. All right, those are good. And actually, I might extend the wires out here, the ones that we're going to test shorting manually. So let's just connect these on the board side, and then we'll kind of circle back on the other. All right, that is good. And nope, that one didn't lock in. Okay, in theory, the wire's repaired, but we do need to extend it out. So I'm going to use a second wire. We'll try to double clip it in. Otherwise, we could use something like this. But given the wire lengths, I don't think we have really enough to do that. We kind of need to preserve the original length. So we're going to try it like that and double up and see what we get. And we'll try this wire. The gauge is probably too heavy. I'm not sure if both wires are gonna stay in there together, but we're gonna use the black wire to represent the ground. Yeah, it seems like it has a hold of both. And we'll do the red one for the switch. And yeah, that one didn't bite. So we're gonna have to try this a couple times, and we're gonna test it again with the multimeter just to make sure that electrically that we're making connections here. Feels good. So same test, we'll do a lead on each wire. And let's push the off button, or the stop button. And yeah, there we go. So it seems like it works. Now the interesting thing too I'm noticing is that when I initially push the button, it does have a spike, meaning the resistance initially is high and then it drops. So I'm not really sure what to think of that. And actually the meter just timed out and shut off right in the middle of using it. So let's turn it back on. Let's try it again. Yeah, so again, I'm not sure what to think of that. You know, it jumps from a couple hundred ohms down to a very low value. So, but the good thing is that it does drop to a low value. And the thing I noticed too, when pushing the button on the front, when testing the machine, if I pushed it for a second, it wouldn't register. You had to hold it for at least 2 seconds. And I'm thinking that initial higher resistance is why. You know, it might be something built into that button. I'm not sure. But I think this will work. So I'm going to get it plugged back in and we can do a quick test. All right, so we are reconnected. I'm going to turn the battery back on. Actually, it was never turned off, but the breakers were. So we'll turn on the controller, which I think was the second one over. And it is powered up. So these are the 2 wires we extended. This should simulate someone pushing stop. So let's just try it real quick, make sure we don't let out any magic smoke. Actually, let's try it manually first. So run still works, and stop still works. Let's just try it like this. No excessive sparks, so that's good. Let's hit run. And let's try signaling it now with these wires. And there we go. So we have a solution to control the buttons with a remote relay. So I need to, I guess, figure out how I want to attach these permanently. You know, we also need to run another wire from the run, and then we just have to worry about the control side. So perfect. All right, so I've got the board back out and I pulled off the wires we used for testing. So the gauge here, it is overkill for what we're trying to do. And I found this other wire harness which has much smaller gauge, you know, still larger than what we're dealing with, but it also has 3 wires, which is what we need. So we're going to use one for ground, the other for stop, and I think the red for run. And what I'm going to do is solder these wires together, and we're going to stick with the Wagos. But with these two soldered together on this side, now the Wago's making a single connection like it's meant to, and then we'll connect the other side up to the board. So we got to do that 3 times. So I'm going to get the soldering iron warmed up, and we'll give this a shot. All right, so that one is good. Let's do the ground wire next, which we'll use the black for. All right, so those two are good. We'll do the run wire next, and I'm actually out of this type of Wago, so I'm going to have to order that up in addition to the relays we need to complete this project. But for now, we can at least get the last wire connected, get the control panel reinstalled, and route this wire harness ultimately to where it needs to be. And the run button, we said, was the 4th wire, so we have number 2 right there. Number 1 is there. That's 3. And this one here, this is number 4. So this is the other wire we need. So I'm going to cut and strip that one back. And that should do it. Now the heat might have melted this insulation a little bit. At least we're stuck. Oh, you know what? These were just there for shipping, apparently. I thought they were there to protect the wire. So looks like I attached that to that, which is not great. And we do have a little exposed wire, it looks like. So I'm going to wrap that, or maybe put a little bit of shrink tubing on that. Let's just check the others. Yeah, a little deformed on the black as well. So yeah, I'm going to put a couple short pieces of shrink tubing just to make sure, you know, this is protected. And it's also going to help on strain relief on these wires. All right, so the ground is the black, which is wire number 6. That one right there is what we need to connect it to. That looks good. I think we said we're going to use the white as the stop. So let's get that connected. Stop is number 4 wire, which is, actually no, it's the number 2 wire. Okay, and that's it for now. The other Wago connector I actually ordered a couple days ago, so that should be here later today. When that arrives, we'll get the last connection made, get this fully reinstalled, you know, run the wire harness where it needs to be, and then wait for the relays to finish this up. All right, 2 hours later, and we have the final connector here. So let's get that connected and then get this board reinstalled. That'll do it. All right, so in theory, that is done, and we can get it back installed. So we're going to do that in a second. You know, it's kind of hard to get access in here, so I'm not so sure I'm going to show a whole lot of that, but we do need to plug in those 3 connectors, and we also need to get this wire out of this box. And the only way to do that is in the top right, and that's already packed with wires, and it heads straight down. So not easy to get to, but I did manage to pull 1 wire through. So I'm going to use that to help fish the rest of it through. So I'm not sure how much of this I'm going to record. Maybe all of it, maybe none of it. But we need to get that installed and the wire pulled through. Now the battery's not energized, but being a positive ground, you would actually disconnect the positive and the negative would actually be considered live. So I'm kind of surprised they have the protection over the positive. Yeah, I would think the negative is what you want to protect on a system like this. And that went pretty well. So we were able to fish the wire through and down, and it actually comes out right here under the box. So we have plenty of extra wire to work with. When we eventually get the relays, we can, likely mount them somewhere here, or potentially in the internal battery compartment, which is not going to be used. There's plenty of space. So for now, I think we've done mostly all that we can. I think I do want to power it up one more time and just test that we connected everything properly. And if that's the case, then we'll just wait a couple weeks and finish it up when the relays get here. All right, so let's try this. We're going to take the ground wire, which is the black in this case, and we're going to connect it to red. That should trigger the system to run as if we're hitting the run button. And there we go. It's trying to start, but the engine's not cranking because we have that main breaker off. And if we touch it to the white, it should go back to the stop position. So that is pretty much perfect. So it is a few days later, and we've got the relays we need to finish this up. So I got 3 in total. They mount to a DIN rail. And the one here on the right, that is a standard 48-volt relay. It has a normally open and normally closed position. The 2 on the left, those are the specialized ones that we're going to use to kind of simulate the button press. So we'll get more into those later and test them and just set them up how we want them. But for now, let's figure out where we're going to mount this, and then we'll get this thing wired up. So originally, I was hoping we could get it in here, under the control panel. I guess technically we still could. The downside is that the space is a little bit tighter than I thought, and this area might be exposed to moisture. We don't have a good weather seal on the door like we do on the control panel. And the other issue is we don't have good access to the backside to put a nut on the backside of the bolt, so it wouldn't be secured quite as well. So haven't quite decided on that. Plan B was to put it down here, but just for ease of access, it's kind of awkward to get down here. Up above, we do have a couple options. I guess initially I was thinking this would be a great area, but after looking at the vents here, this is actually going to run hot engine air through here. And these relays, I'm not sure how much of that it can take. The compartment over here actually would be ideal because it's segregated, except we have propane running through here. So if we have a leak and one of the relays clicks, that could ignite the fuel. So I would say that is out, that is out. Down here is a definite maybe. And even lower, that might actually be the best spot, just not the easiest spot to work in. So I think given our options, we're going to go this route, and I did find a way to access the backside so we can get a nut on there pretty easily. So I'm thinking right about there is where we want to mount it. So let's mark that. So let's see how we did here. Yeah, looks pretty good. So let's get on the back side. We'll get some nylock nuts on there and tighten it down. And that's what I was afraid of. I thought we were going to come through right down here underneath this piece, But we actually came through underneath that piece right there. So yeah, not going to be easy to get to. Yeah, it looks like if we remove this panel here, then we might get access to that compartment. Yep, and there they are. So let's snug those down. So let's just make sure it installs. And yeah, looks good. We have just enough clearance here on the top and bottom to make this work. So let's get this back off. Let's configure it for our needs, and then we'll finalize the wiring. All right, so we're going to test this relay. This we have to set up. It configures a bunch of different modes. In our case, we don't care about these other modes. Really, the interval one is the one we're interested in. So that's the one we're going to focus in on. Now, I guess the row here labeled by U, that represents power. So when we apply power, the relay closes for a set amount of time, and then it opens up regardless of whether the power is still on or not to the coil. The only way to get it to trigger again is to disconnect power, reconnect power, and then it stays on for that set amount of time. Or if the power is removed before that set of time, then the relay shuts off. So in our case, I'm thinking we want about 2 or 3 seconds to simulate that button push. So to do that, we first need to set this in mode C. And if we look here, the bottom knob, those are the different modes. So right now we're actually in mode A. There's a little arrow right there. So we're going to turn that 2 clicks to mode C. And then to set the amount of time we want this to stay on, you have to actually adjust these two. These work in tandem. Now, this top one sets the time interval. So in the, leftmost position, that's 0.1 seconds to 1 second, which we don't want. But if we move it 1 over, that'll be 1 to 2 seconds. Which is right there. And then the middle adjustment, that represents the percentage of the 10 seconds you want it to stay on. So the default position, I believe it is set to 0. Let me just double check that with the chart. And it actually doesn't say on the chart, so we're going to have to zoom in here and see if we can read what this says. And yeah, it's kind of hard to make out, but hopefully you can see that. So that's set to 0.1 right now. So 0.1 of 10 seconds is 1 second. So we want to turn that to the 2 position, so 20% of 10 seconds is 2 seconds. And this is actually an analog control, so it doesn't click in place. So I'm going to set it a little bit above 2. And then we can test it. So power goes in here. The good thing about this relay is it's universal power, so anywhere between 12 and 240 volts. AC, DC, 50 or 60 hertz should work just fine. So we're going to hook that up to 12 volts DC. And on the output side, we're going to switch the ground. So I've got a light connected to a battery. Right now, the positive is connected. So what we're going to do is connect the negative through the relay. So we'll do one lead on the output of the relay, which will be the switched negative. And the other end of this is going to go to the light bulb. And then we'll run another jumper, which is connected to battery negative, to the common on the relay. So right now, this shouldn't light up because the relay, well, the positions we're in is in the normally open position. So right now, these two wires aren't making a connection, but if we power up the relay, it will make a connection for about 2 seconds. So let's try that. So we're going to hook up positive to the coil side of the relay. And we're going to do the same for the negative. So as soon as this connection's made, the light should turn on for approximately 2 seconds. And you can see it's instant. And there we go. So that's our button press. Now, this won't happen again until we disconnect the power, reconnect it, and it stays on for about 2 seconds. So that is exactly how we want it. So I'm going to do the same just for the other relay. One will be used for the on press and the other the off. And I think it's safe to get these installed in the machine. So we're just going to get all these snapped in place, run a bunch of wires, and we'll do some testing. Make sure it works as we need it to. And this is where things are going to get a little bit confusing. We have to run power down to those relays, and I want a fuse in circuit, but these automotive fuses, they're only rated at 32 volts. And of course, we're going to be running in the 50s. So I did order a fuse that is rated for 58 volts, but we don't have it yet. So for now, we're going to be running with one that is improperly rated, which means if this blows, it may not blow cleanly. So we're going to have to keep an eye on that. The other confusing thing here is going to be the way we do this, because usually you fuse the live wire. And in this case, the live wire is neutral, or I should say negative, which is black, not red. But all these fuse holders, they seem to only ship in red. So we're going to have to use some shrink tubing to denote the proper wire color. So this, despite the color and the fuse, this is going to be connected to negative. All right, so now that we have that connected, we'll shrink the tube down in a minute, but we now have to extend this down to the relays. And for that, I was just going to use this 18 gauge wire. It's more than adequate to run the relays, and it is the proper color. I guess the only complication is that this is 18 gauge and this is probably 12 gauge. And a standard butt connector, I don't think will combine these two wires. So we could actually use another Wago connector, or we could also use a butt connector. I'm not really sure it matters which we use, or we could actually use spade connectors. But I kind of like the idea of the Wago because, well, I was going to say because it's easily removable. But as I say that out loud, I'm thinking maybe we use spades instead. Actually, no, we'll use the Wago. It's rated for, I think, 12 gauge to 22 gauge, and it will safely connect these wires. So the spades, it's more traditional, I guess, but I don't see any big benefit to it. All right, nice solid connection. Do the same for the 18 gauge wire. Perfect. So we're going to hook up the battery negative right there. We have an open stud. Not sure what it was intended for, but it's not used in this application, so we're going to use it to power the relays. And we're going to do something similar here on the positive side. The only difference is we don't have an open stud to use, but we do have these smaller screws right here. This one has 2 ring terminals on it, so I'm thinking we can just add a second to the one over there. So, in case I didn't state this, I'm using white as red with this red shrink tubing here. It's just interesting that OEM, they're also using white with no shrink tubing as positive. All right, so that install is complete. I've got all the wires secured, kind of following the original factory wiring harness. They come right down through here, zip tied in, and they exit down here. So we're going to leave those for now. We'll circle back and connect them later. And I think next we need to run all the wires to the relays, and then we'll combine everything and test it out. So we're going to get this relay back in. This is just the main one that switches between, the stop and the run relays. And technically, I'm installing this upside down because I want the coil power to all be on the top and then the outputs of the relay to be on the bottom. So yeah, it's definitely going to be tight on the bottom side, but I think we can do it. So I'm going to start by wiring power to each of these relays. We're going to wire in the battery positive, which is the common or the ground. So we're going to connect one lead to each relay. We'll tie that in later with the wires coming down. And then we need to run the negative side, which is going to be the switched side that ultimately is going to control the output down here on the bottom. Okay, that wire is secure. And we're going to run it, probably and zip tie it to these wires here, but for now we'll just cut it with some excess and worry about combining after the fact. Okay, so we're going to leave the negative off for now on this relay. That's what's going to be controlled by the charge controller, which ultimately is going to select either stop or run. So what we need to do next is connect the negative to these two relays, and that's going to be controlled by the output of this one. So we actually have two separate sets of contacts. We don't need both here, we just need one set. So I am going to use probably this set over here, and it's very hard to see, but there are 3 terminals. This one is the common, normally closed is way back here, and normally open is right there. So we want to supply negative power coming in. The normally closed is going to go to the stop relay, and then the normally open, that is going to run over to the run relay. So I'm thinking instead, let's actually wire it first to the top here. That way we can zip tie everything together, make it nice and neat, and then cut all these wires to the final length. So now we're going to connect this black wire here to the normally open connection point down here. So when this relay is not energized, that relay will have power. All right, so that is secure, and then we'll hook up the other relay so that when this is energized, meaning it's calling for power, this will power this relay over here. So this wire is actually maybe a little bit too long, so I'm going to cut that back a bit. And last but not least, we have the power feed going into the common. So this is going to be full-time battery negative. And depending upon the state of the relay, it's either going to send negative to the relay in the middle or the one on the right, energizing it. And that just leaves us with all these wires that we've run down. So these 3 wires, they are the power wires to each of the coils on the relays. We want these to be full-time positive, which is this wire right here. So we're going to use another Wago to essentially turn one positive wire and split it to feed 3 others. So we need to cut these all to length, connect the Wago, and the positive side will be done. And we are going to leave a little extra wire here in case we make a mistake. But we'll cut it right there. Adding that shrink tubing actually makes it a pretty tight fit. So that's actually going to help with the weather seal. All right, that was good. And that just leaves the ground wire. So we have one coming down from the battery, and it needs to be connected over here to the common on this relay. And then it's going to switch the ground between these two relays, energizing, whatever relay we need, depending upon the status of this relay. So this relay also needs a ground on the coil side. So we need to split this one into 3. Although just note the relay up there, that is only going to be energized by the charge controller. So the third ground wire, that's going to run about 30 feet into the house where the charge controller is. And when that relay closes, it'll then send that negative back up into the coil on this main relay. So I think we'll cut this one right about here. And we'll strip that back and pretty much do the same thing. We're going to add a ferrule as well as a Wago connector. And that brings us to the control wires. So we have 3 in total. Black is ground, red we designated as run, and in retrospect, might have been better as stop. And if I had wire colors to choose from, green would be better for run. But as it is, run is go. So we want to put that on the relay here on the right, on the rightmost terminal, and the white wire is going to go on the left relay, again on the rightmost terminal. And on the left terminals on each relay, we're going to connect up a black wire, which is going to be, the ground that we extended from the board. So similar, we need to use a Wago to make 1 into 2. And similar to before, we're just going to cut it, probably right about there. We'll add the Wago. And we'll be more or less done. I just need to rig up the trigger to kind of simulate the charge controller, making the call. So I double checked the wiring, and I actually did find a problem with this relay right here. I thought the common was up front, but it was actually in the back, so I had to swap those two wires around, but everything else looks correct. So theoretically, when we turn the battery on, the only thing that should happen is that the middle relay powers up. That is the stop relay. Should activate for about 2 seconds and then shut off, and nothing else should happen until we throw the switch. And when we do that, it's going to connect these two wires, energizing this relay, which should kill power to the stop relay and energize the run relay. So I guess there's nothing to do but try it. And we're powered on. So the correct relay came on for 2 seconds. Everything looks good. Let's flip the switch. And yeah, that is absolutely perfect. So this relay energized, killed power here, sent power to the run relay. So in theory, we should be good, but we haven't tried it with the control panel yet. So let's power that up and make sure it has control of the controller. So let's energize the controller. And by default, it's going to come on in the stop state, which it did. So let's flip the switch. Should go to run, which it does. We'll flip it off, and it goes to stop. Try it again. Perfect. So on the surface, things look pretty good. The relays, they are working as designed, and the controller is responding properly to those inputs. The issue is actually something I overlooked on this relay right here. There's actually two issues I overlooked. First is the output contacts and the voltage rating. At DC voltage, at the rated current, it's only rated for 28 volts, which this system is going to be approaching 57 volts at times. So, I guess the good news is that voltage rating increases as the amperage drops, and these relays right here pull almost nothing. So I think we'll be okay using this relay with these contacts and the voltages involved, at least on the contact side of the relay. The coil side is actually a bigger concern. The coil here, it is rated at 48 volts. The issue is the upper range of that voltage rating is around 52 volts. And the lower range, I think 38 volts. So if we go above that rating, we're going to create excessive heat, and that relay is going to fail prematurely, which is definitely going to be an issue because right now, at 39% state of charge, we're sitting at 52.39 volts. And when this battery is fully charged, we're going to be closer to 54 volts. And while it's charging, we could actually approach 57 volts. So this relay can't handle that voltage. So we need to decrease the voltage going to that relay. And there are a few ways we can do it. A DC to DC converter would definitely do it. But I'm thinking a resistor might also do it because the load that this pulls is only about 0.9 watts. So to drop the voltage by a few volts, I think we can use resistors that I have on hand. Or to clarify, resistors that my son has on hand. He has a bin of resistors, and I did find one that's rated at 330 ohms. And I tested it, actually comes in at 327, so I think that'll be fine. I've crunched the numbers, and, based on the math, assuming this is a 1/4 watt resistor, which based on the size, I think it is, we should be good. At 48 volts, we're going to pull about maybe 1/10 of a watt, and even at 57 volts, we're only at about, I would say, 0.15 watts. So yeah, a 1/4 watt resistor should be fine. So let's get that in circuit and see if that fixes the issue. All right, so actually before we put the resistor in line, let's just double check the voltage at the coil. It should be battery voltage, which is 52.4 volts. And yeah, we're at 52.5. So by adding the proper resistor in line, we're going to drop the voltage. And based on the calculations I did, this is going to drop it by around 6, maybe 7 volts. So the voltage should come down from 52.5, I would say closer to 45, which would be a lot safer range because this can operate between 38 volts and 52 volts. So if this drops it by 6 volts, even at 57 volts, we'll still be within the operating voltage range at 51. So let's turn this on. And the resistor seems fine. Let's double check the voltage. It should now be around 45 volts, I would think. And yeah, we're at 45.9. So that is perfect. So I've kind of let this relay cook for a while. It's been about half an hour, and that resistor still nice and cool to the touch. So we are good to go. I've kind of buttoned everything up. We got all the wires secured and add a couple spade connectors as well. So Darren can tie his system in just with these 2 connectors right here. We've got the battery box cover back on as well as the side panel. So I do want to get this outside for one more test and just make sure that this is ready to go. So I've got things just about ready to go. Now, this test is going to be very similar to the last one we did, but there's going to be 2 notable differences. First, instead of using the buttons to start and stop the machine, we are going to be using the remote switch to perform those functions. The second thing is that the load we put on last time was 30 amps. This time we're going to do 60. So I've already made and set those changes, and we're going to get away with it because we've also added an inverter to the battery. So we're going to run this space heater at 1500 watts. That's going to pull about 30 amps from the battery, offsetting the 60 coming in. So 30 will go to the battery, 30 will go to the space heater. And then at some point, I might put that on low, bumping the amps up to 45 to the battery. I'm kind of curious to see if it can handle it. I think it can, but we don't know what we don't know. So let's get the engine started, or actually before we do that, I did receive the 68 volt rated DC fuse. So let's swap that in, and then we'll try this out. Interesting. Fuse came out with the cap. So we'll put in the higher rated fuse. Very similar form factor, but this one should be safe for what we're doing here. Well, we're starting at a 39% state of charge, and I'll actually put this screen up on yours. But if you look at the electric section, it says 0 amps. And we want to put a load on it first of 1500 watts, which translates into about 30 amps. So yeah, looking at the app, we're now at negative 29.4 amps, about 1500, a little bit more than 1500 watts. So let's get the engine started and see if we can put some power back into that battery. All right, no issues at all with the remote start. It started right up, and the amperage also ramped up. It started kind of low, but now, according to the meter here, we're at 62 amps. So 30 of those amps should be consumed by that inverter, and if you look here, the remaining is going into the battery. So we're putting in almost 35 amps into that battery. So we'll give it a bit of time. I want to get to at least a 50% state of charge. and then we'll shut it down. Well, so far so good. It's been a few minutes and state of charge has come up to 41%. So I think things are going as planned. I guess the only thing to watch out for is that, this heater has a thermostat in it. So at some point it decides that it's hot enough and shuts off, then we're going to start putting 60 amps into the battery. So if that happens, we'll just shut things down. All right, things are looking pretty good. Engine's been running for about 20 minutes and we're at 47% state of charge. According to the controller, 35 amps input, voltage is 54.28, and the meters here closely agree. We're at, 61.3 because that is the total amperage between the battery and the space heater. And the multimeter here says we're at 54.9 volts. So we'll give this another 10 or 20 minutes, and I think we can shut it down. So things are progressing just fine. We're at a 54% state of charge. Voltage about 55 volts, and the amps going in largely unchanged. So I'm going to do a quick little test on the BMS just to see if it can handle more current. Right now we're at 35 amps. So if we put the space heater on low, it should bump it up close to 50 amps. And yeah, we're at 48.9 amps. And it is doing it. So yeah, it's good to know what it's capable of. Obviously, it's not great for the batteries, and it's going to heat things up. So I'm going to put this back on high and let it run just a bit longer. Yeah, I think I'm going to call it. We've been running for half an hour without issue, but at this point the shadow is moving, and pretty soon the space heater, inverter, and battery are going to be in the sun, and something's going to overheat. So, at this point, I'm going to call it good. We're at a 58% state of charge, and have had no issues at all. All right, guys, and that is pretty much a wrap. Overall, a very impressive machine, and I think Darren's going to be very happy with it. For $1,000, he got a heck of a deal. I mean, the engine alone is worth about 3 times that, not to mention the Alltrax golf cart motor. Definitely a unique combination of technologies, and I really like the fact that it can be configured, because in the state we got it, out of the box, this was designed for lead acid battery banks. And we were able to reconfigure it for Darren's needs and enable remote start. So now he can hook this up to his lithium-based battery bank and charge it when there is no sun. So I hope this video helps someone. Thanks for watching.